Hi guys, in this video we are going to learn about a problem that is known as leaders in an array. Leaders in an array are those values which to its right do not have any value which is greater than it. For example, in this particular array, let's take the second array. If we are considering 10, to the right it has 20 and 30. So 20 is greater than 10 and 30 is greater than 10. So 10 is not a leader. For 10 is not a leader. For 20, the right is 30. So it is greater than 20, so it is not a leader. But 30 to its right, it has no values, so 30 automatically becomes a leader. So as you can see from this particular case, that the last element is always a leader, okay? And if you are considering this particular case, let's take 7 for example. So here the output would be 30, which is the leader. So in case of any sorted array in ascending order, if you are provided any array, the leader would be the last element, okay? So for example, in array, if you are provided these particular values, I am taking 7 and I am taking these values, that is 10, 4, 10, 6, 5, 2. So now I have to check whether 7 is a leader or not. So I will iterate through all of these and I will check whether 7 is greater. For the first value only I am getting that it is less than, so 7 is not a leader. For 10 I would be going through the same thing, and as you can see that 10 is equal to 10, you must also remember leader, a value is only a leader when it is greater than all of its element present in the right, not even equal to. So this will not be a leader, this will not be a leader, 4 would obviously not be a leader. But see here 10 is greater than all of its right elements, that is 6, 5, 2, so 10 would be a leader. 6 is greater than all of its right elements, so 6 would be a leader. 5 is greater than all of its right, all of its element on its right, so it would be a leader, as well as 2. So the leaders of this particular array are 10, 6, 5 and 2. So these are the leaders. And in case of another case, that is a descending sorted array, you can see that the first element is larger than already the second and the third element. So 30 would be a leader, 20 would be a leader since it is greater than 10, that is the last element, and 10 would be a leader because it is the last element of this array. So first we would be trying to solve it in a naive manner using an order of n square, where we are taking an element and we are comparing it. We take an element I and we compare from j is equal to I plus 1 to j is equal to n minus 1, and we compare all of the elements. If the elements have a lower value than the array of I, then we consider it to be a leader, otherwise it is not a leader. So let's go to our pie chart and let's start coding for this particular solution. But you can see that this particular solution is order of n squared, so it would take a longer time to execute. In the next example, we would be trying to solve it in a much more optimized manner. So let's go to our pie chart and let's start coding for this particular problem. So def leaders. So in case of leaders, we would be providing two parameters, that is add and n, where n is the length of the array. Now we would be iterating through all of the elements in the array. So for I in range n, so I is referring to the indexes of the array. Now for each element I would be creating a flag. For first it is 0, and we would be changing its value as we proceed. So now you will see how to change its value as we proceed, okay? So now you have the element ai, array I, okay? Now you have to check to its right whether all of the elements are less or not. So for j in range I plus 1 to n. Now I would be iterating through all of them. So if r of j is greater than, it must not be greater than, always remember that if r of I is a leader, then r of j cannot be greater than r of I. So this is a wrong condition, and if this condition becomes true, then automatically r of I is not a leader. If r of j is greater than r of I, then I have to set my flag is equal to 1, that is, it is not a leader, and I have to break through the current loop. Now if flag is equal to 0, then let's print the value of r of I. Okay, so these are my so this is how, using the n squared, we can print the value of the leader using n squared time complexity. Let's write the code for it. So let's write the input for it. So r is equal to, the input would be 7, 10, 4, 10, 6, 5, 2. So as you know, 10, 6, 5, 2 must be the leaders. So leaders I am calling r and len of r. Let's run our code here. So I am getting 10 2 times and 6 5 2. That must not be the case. So I have provided a wrong condition here. As I told you, if it is greater than equal to, then also I have to consider it. It must only be less than. So 10 6 5 2 is the expected answer that we are getting. So in the dry run also, we had seen that we were getting 10 6 5 2, which is equivalent to a code that we are getting here. But this particular code runs in order of n square, and we need to optimize it in order to run it for a larger length of array. Okay, so let me just remove this particular code and this particular part also. Yeah, now for the optimized solution. So in the optimized solution, we would be traversing from the end. So as you can see, the last element would always so as you can see here, the last element would always be a leader. Now the current leader is this. Unless I find a value which is greater than the current leader, it would not be a leader. So I found 5 is greater than the current leader, so it would also be a leader. Now the current leader becomes 5. Now then I would be going to the previous value. So I would have to iterate like this only till I reach the end of the till I reach the beginning of the array, and then I would be getting the leaders with the help of the current leader. So for example, if I'm considering 10, 20 and 30, this is my current leader, right? Cur leader. So cur underscore L is my current leader. I would be comparing it with 20. Since it is greater than since 20 is less than the current leader, since 20 is less than the current leader, therefore we have to not consider it, because it cannot be a leader because current leader is greater, and also 10. So the only leader that we have is 30. But always keep in mind that it would give you an output that is reverse to it, because first the current leader would be 2, then the current leader would be 5, then the current leader would be 6, then it would be 10. So you would be getting in a reverse manner. So you can solve it using string concatenation, or you can just reverse append it to an array, and you can reverse the elements of an array, of the particular array. So let's now just code the leaders function for this particular problem. So def leaders, this is the naive approach. and it would be def leaders 1. Now for def leaders 2, I am providing two parameters, add and n. Now I would be starting from the end element. So my current underscore leader, so current underscore leader would be equal to add of n minus 1. And if we want, we can print our current underscore leader here. Now you have to iterate from n minus 2 till the beginning of the array, and you have to check whether you are getting any value which is greater than the current leader. If it is greater than the current leader, then it automatically becomes a leader, because to the right of it the maximum value is the current leader, and if it has a value greater than the maximum value, then it automatically becomes a leader of that particular array, of that particular sub array. So I would be iterating through for I in range. I would be starting from n minus 2, I would be going to 0, and the step would be minus 1. Okay, then I would have to check if cur underscore leader is less than array of I. If the current leader is less than array of I, then I would be considering that array of I is my current leader. So let's current underscore leader is equal to array of I, and let's just print current underscore leader, that is current underscore leader. So I would be getting my current underscore leader every time I'm getting a value of array of I which is greater than the current underscore leader, which provides the maximum value from the right hand side of the array. And now if I'm providing leaders 2 here, I must be getting the same output, that is 10652. Let's run our code here, and I am getting 10652, but as I had said before, we would be getting it in reverse manner, that is 25610, and we can solve this using a string variable where s is equal to, let's keep an empty string, and it would be s plus equal to s is equal to s plus it would be s plus, or yeah, it would be s plus, there would be a space also, and current underscore leader. And in this also we would have to add s is equal to s plus current underscore leader. Let's and at the end of it, let's just print s. Let's run our code. Yeah, I'm getting an error because current underscore leader is an integer value, and I need to convert it to a string before I am concatenating it to a string. So let's run our code here. So I'm getting 25610 again. I guess I would have to provide this part at the end of it. Yeah, because the last part, yeah, this would be this. Because I'm appending my current value at the beginning, and because 10 would come at the beginning, and we must be getting 10652 as our output. Let's run our code. So we are getting 10652 as our output, but I guess I made a mistake here by providing space here, not before that, and it would also be removed here. Let's run our code. I'm getting 10652 as our output. So this is how we reduce the n squared of the naive approach to an order of n, where we are just in one iteration calculating the leaders of an array without going into my inner loop. So thanks for watching this video guys. I hope so this helped you. See you in the next one.